The recording back on. So we're recording now. I'm going to go back to sharing my screen here. And let's go ahead and do this here. All right, so that was Chester in our celebrity interview. Oop, going the wrong direction here. All right, so just a few comments on our lean movie. So the movie last week was Stockless Production. It was H.P. Greeley. This is sort of a classic. A little background on that movie for you guys. Although I worked for Hewlett-Packard for 11 years, the first time I ever saw that movie, and I think the movie was made in 1984 or so, the first time I saw that movie was in the mid-'90s. It was when I went to Motorola University and sat in on one of their lean classes. And it turns out that everybody in Motorola would see this movie and they would show it to them as an example of what they were going for in trying to create a stockless or lean type production process. It's kind of interesting seeing where HP started with that and the approach. But very powerful idea. Any comments on the movie or things that people want to share, insights that they gained from that, things that they think that they're going to apply to maybe their project? So if you do have a comment, if you could raise your hand, I'll go ahead and recognize you. All right, Dominic, yes, question.
Question or more of a comment. I've been involved with it, the dice game, similar, so for those who are unfamiliar, Eric, I don't know if I personally don't know a good resource. I think that would be a good potential icebreaker for like a lean team, especially if you're trying to explore that kind of reduction in variability. Also, there's different variables of that dice game, but I don't know if that's something that is relatively cheap, inexpensive to put together, as a proposal, maybe for some of the those new and experienced to kind of see it that way versus, this was a good visualization of I guess what that game is trying to achieve.
Right. So Dominic, when I've seen a lot of different dice games and things. So do you have one that you could share with the class, or maybe you could is there a link to it on a website somewhere? Or?
Let me pull it together. And Chester, I don't know if he's still on, but he or maybe he's still there. But with our director of Lean, that's something that has been a great success. In the way that he kind of coordinates that. So maybe I can share something with you in the class, get what he has together. But I'd like to offer that because it's a quick game and it's a good team builder.
Okay.
Gets everybody in that kind of mindset. So I wanted to offer that.
Yeah, I've got my own versions of different dice games and stuff. But it's interesting when you do those sort of lean simulations and the kind of thing you saw in this movie. They illustrate different concepts in lean, right? And so these guys at HP did it in kind of a fun, interesting way. But they're really driving home some key concepts about the relationship between cycle time and inventory, how important it is for operators to talk to each other, to get the involvement of the engineers in the production process and not be so dictatorial. But there's a lot of good concepts there, and these different simulations and games draw out some of those concepts better or less well, I think. Yes. But thanks for sharing that. And if you do come up with something I could share back with the students, please do.
Sure, okay. We'll send it.
Great. Hey, Chester, you're gonna comment back in?
Yeah, I was just gonna agree with Dominic. The dice game is a really good one. The general idea is that each person gets a dice and you roll it, and that's the amount of material you can pass on to the next one. Right. I'll definitely ask our boss tomorrow at work if we have a slide or a PowerPoint or something, but it's pretty simple. Another one, I'll forward the PowerPoint to you, Eric, is we have a 5S game, right? So 5S can be really hard to sell to people. I'll let you look at the slides and you'll see the benefit of it. But it takes about 10 minutes to play, and it's also a pretty good exercise.
Yeah, yeah. And, you know, one of the things I'm looking for in this class too, as we try to improve this class in an online format, you know, what can we do with, you know, chat rooms and different mechanisms online here to simulate some of these things. So I'm looking for those sorts of opportunities also. All right. Any other comments on the movie? I'll go ahead and move on then. All right, so as far as tips and tricks, also looking at that blue left-hand menu panel on the MoreSteam training, you'll see something called Stat Master. And we just went through the measure stage, so and we're going to go into analyze. So a lot of statistical analysis, different tools and things. So this is a real nice sort of automated decision tree type tool for you to use. So, for example, if you decide that you need to ask a question, do you want to describe a process or a group of data, you select that. It'll point you down a tree to certain tools that are better or worse at doing that. So this is good. There's also a similar type mechanism, a wizard in the engine room they could also use. And I've got this little note here at the bottom here. You know, the secret to good hypothesis testing, because we're going to get into hypothesis testing in the analyze phase, is to plot the data first. You know, by all means, try to make it visual so you can see what's going on. Okay, so that's our tip and trick for this week. Whoops, let's see. I guess I had that slide in two places. But anyway, what I'm going to do is I'll go into our highlights. So this is in session 7, measure 3, charting process behavior. If this is your first introduction to control charts, well then welcome. One of my favorite control charts is this XMR chart, or X and moving range chart. One of the reasons I like it so much is typically in control charts, when you first learn about them, you're learning about X bar R charts, and they talk about, you know, grabbing a certain sample size, like grabbing, you know, 4 or 5 pieces of some machine component and measuring them. The nice thing about this X and moving range chart is you can just work with individual data pieces. And the moving range allows you to do that as you go through. So we're going to do a little example and talk about that. But the big thing about control charts, you're trying to keep things in your process between the upper and the lower control limits. And you're looking at not only the center of the process, which is that individual value or the X bar value, and you're also looking at some measure of the variance or the range. So you get the moving range there on the bottom. Let's see. There's also in this section the idea of process capability. So what we want to do is we want to know, first off, is our process even capable of meeting the tolerances or the customer requirements in the first place. So that process capability, there's 3 ways that we can achieve our process capability. One is to center our process. So I'm sort of hovering our, let's see, I'm going to turn on my annotate capability here. And let's go ahead with the draw here. So if I'm looking at my process capability, one thing I could do is I could move the center of my process so I could do a better job of centering. I could also reduce the variation in my process. So what I want to do is I want to reduce that total variation in my process. So if I do that, the other thing I can do is I can actually, you know, heaven forbid you should go talk to your customer. And maybe these control limits can be moved out. Maybe they're tighter than they really need to be for delivering a certain level of performance. This really happens a lot in engineering, because when engineers put these control or these specifications on or control limits on their process, Give me a second. I turned off my marker. Whoop, coming back. So as engineers put these limits on some value, it's always easier for them to put these limits closer together, right? Or to make that process tighter, because they would have to think less and they'd have to worry less. So if they're very conservative, they're going to go ahead and put those limits tighter, and maybe tighter than it really needs to be in order to deliver the performance. Now, I talk about engineers, but it also happens to managers. People are always trying to guard band and make things tight. Well, my answer to that is, at least for trying to improve your process capability, start with limits that really reflect what the customer needs, not just something that somebody woke up and had a bad dream and said, okay, we got to be this tight. Well, what does the customer really need for that? The other thing is that this idea of over control situation. So an over control situation says that when things are within specification, so if they're inside these limits and they're happening, inside here somewhere, you don't want to be like changing the settings or introducing changes or improvement. As long as the stuff is between the upper and the lower control limits, you're okay, right? And you don't want to over control. So if you're in there tweaking and changing the specifications and changing the requirements and doing things to try to get that tighter, you want to do it in the right manner. And the right manner is when it's out of control. That's when you step in and you analyze, you stop the process, you analyze, you try to figure out what went wrong. If something went wrong, you fix it. If it didn't go wrong, you say, okay, once in a while things will get out of control. They will go, outside the limits, and you rerun it and you watch it as you go forward. Okay. Any questions about control charts? Anybody want to make any comments on that? Questions about things they saw in MoreSteam? Okay. Well, like I said, I'm going to share a little example with you in a moment here. So let me move forward here. And I'm going to turn the mouse back on. Okay, so let me clear my scribbles here. Okay, so what I want to do is the last couple weeks, because I was working at remote locations from Yosemite last week, and the week before that, I was up at Sonoma State using different computer systems. I wasn't able to do some examples with you. So what I want to do now is I want to walk through an example of from St. Sigma, which is a little simulation that MoreSteam provides. So you can see down here we've got a control chart selection, decision tree. Which control chart do you want to use? Is the data continuous or discrete? And if it's continuous, do you have subgroups, greater than 10, 2 to 10, or individual observations? Well, we're going to kind of go down that line for an example with St. Sigma from MoreSteam. All right, so with that, let me see here. Let's see, escape out of this. Whoop. All right, there we go. So let me go over to okay, so I'm going to go to MoreSteam. I'm going to go ahead and launch this simulation. So this is a little example. We've got a hospital, like other hospitals and healthcare systems in general. They're struggling. They're under tremendous pressure to improve patient care, patient outcomes. So that's the general problem that they're looking at. So we meet Laura Watson, who's runs the lab at St. Stigma. So she's looking particularly at some of the blood tests that they do at St. Stigma, and things are often needed in a hurry or on a stat basis, but on occasion it can take as long as 2 hours to perform a blood test. And one of the things we do, and I would recommend this to you when you're looking at your projects and collecting data, pick something specific. And in this case, Laura picked a high runner. They do a lot of glucose blood testing as a thing that they're going to look at. So if you pick a high runner, generally there's more data available. It happens more on a regular basis. And quite frankly, if you actually fix the high runners, a lot of times it'll suck a lot of the less frequent runners along with it. So my hypothesis here would be if they improve glucose blood testing, a lot of the other testing will also get faster. So we're going to get organized. Laura, quite rightly, is going to take a DMAIC approach. Surprise, surprise. So define, measure, analyze, improve, and control. And they've got some key questions that she's wondering about or asking as she goes through. And so now here's the process. So we're going to take a look at this process that they use for glucose blood testing. And here's a little animation of that process. We can kind of see the arrows. So I'm going to go ahead and replay this again. But essentially, their step one is the receipt of the sample. Then they go to the centrifuge. And then they walk to the analyzer, then they load the analyzer, and then they analyze it, and then they post the results. And there's the doctor getting the results for the patient. All right? So I'll just go ahead and replay that simulation one more time. You can kind of see that.
Eric, sorry to interrupt here. I don't know if I'm the only one, but I cannot see any of this.
You can't see any of this?
No, I see your highlight reel. I see you. I mean, my screen's not frozen because I see you.
Okay.
I can't see it either.
Okay.
Screen sharing. Hold it. Yeah, I've got a message here. My screen sharing is paused. What does that mean? I'm gonna stop sharing for a second. Thank you for raising a red flag here, Dominic. Let me go back and see. Tell you what, I'm going to try to, I was doing a desktop share. Let me try to share the application directly. So Dominic, since I was talking to you, can you see
I see your cursor.
See my cursor?
It's white, the screen.
The screen is white.
So I see your browser.
Mm-hmm. Okay. Interesting.
I don't see any simulation.
All right, I'm gonna try to jump ahead here through here and get to the next part. Let me just and what I'm doing now is I'm gonna. Oh, it's not anything. Let's see here. All right, what I'm doing, just so I'll sort of talk through. So I've downloaded the data for this process onto a spreadsheet, and I'm going to try to cancel, edit. Okay, boy, this is like a cursed thing here I'm working on here. Cancel. Let me go back. Stop share here. Still recording. Let me go back to my desktop here. I'm going to beat this thing this time. One way or the other here. All right. Copy. All right. So I got that. Coming back here. All right, I'm going to try share screen again. This time. All right. So, can you guys see an instance of engine room?
Yes.
Okay. All right. Let me try this. So maybe this is sort of where we're going to stop. So I'm going to go to. All right. So what I've done is I've got some data that I'm going to share with you in a second from that St. Sigma simulation, and I'll have to play with that to find out why that wasn't showing up on the screen. But I'm going to go with maybe they have some protection or lock on it or something. MoreSteam is treating that as proprietary or something. So I'm in engine room. I'm going to go ahead and open up a new project, right? And I'm going to go ahead and put the data in my project. So I clicked on the add data, and I've got a new data source. I'm going to push that down. I'm right-clicking. I'm going to drag that to the left. That opens up a spreadsheet, and I'm going to right-click, and I'm going to go ahead and paste the data that I downloaded from MoreSteam. And here's the data, all right? And what I have here for data that you can see is I've got the observation, the hour of the day that the observation occurred based on a 24-hour clock. I've got the actual glucose testing. Let me see if I can spread that out. Total cycle time in minutes. I'm going to spread these out so you can see what these look like there. All right, the total cycle time in minutes for each one of these. So and then I've got the order priority, whether it was stat or routine. So what they could do in this hospital is they can mark a test needed to be either done routinely or need to be done stat so that they can rush. I'm going to go ahead and save these changes. So I've saved these changes. I'm now going to go into measure here. And what my question is this process really in control for St. Sigma? So I'm going to come into the control charts under measure. I'm going to come down and I'm going to do an X and moving range chart because I've got a bunch of individual measures. Let me go ahead and move this up into the center of the screen here a little bit. And what I'm going to do is, let's see on this data, I've got these little icons that can actually sort of give me a little bit of a preview of what the data looks like. So there's the observations from 1 to 100. So this is a sample of 100 pieces of data. There's the 24-hour data histogram. Here's what the total blood glucose process cycle time looks like when you combine both the stat and the routine. And then if I wanted to look at that order priority, that's a text field because it has ABC on that, so I can't really see a histogram of that information. So what I'm going to do really is real quick, I'm just going to take that blood glucose, so I'm right-clicking on that, and I'm just going to drag that over into the data variable. You can see right there. I'm going to put that in there and let Engine Room do its thing. Okay, so now what I've got is I've got a individual moving range chart. So I've got the X chart in here, and it looks like everything's under control. Over here in the chart statistics, it's kind of small, but you can see where we've got the upper control limit and the lower control limit and the average, right? And down here now, if I want to switch over and take a look at what's going on with the range, so the X looks in control. I look at the range, and it looks like we have one data point that's out of control on the range. And if I hover over it, I can see that it failed test number 1, which is the data, and it's at data item 52, and it's got a cycle time of 106 minutes, okay? So right away, I've got a real feel for it. It looks like the range is out of control, and it's an issue that I want to look at and investigate further before I went and proceeded and said this process was in control. Now I'm going to step back and take a look at some of the settings and things I can do. So for this, there's my X chart. If I wanted to change my X chart, I can put down, this is blood cycle time, and provide a little bit more information there on the value. I might want to say this is my cycle time, minutes. So I have a more correctly and fully labeled chart here. What I'm also going to do is I'm going to go into settings here and see what kind of settings I can have for my control chart. Let's see, I could actually use the median instead of the mean, which might be interesting. Use first stage limits for the entire chart, so I could set some sort of, say like the beginning samples of my chart are what determines the limits, and the later stuff is the stuff that I'm monitoring to. I can show standard deviation on the chart, so I'm going to go ahead and turn that on because I'm interested in what that standard deviation looks like. And then I also know that I could set my lower limit to 0 because it doesn't really make sense to have a negative cycle time. So I'm going to go ahead and turn that on also. And I'm going to go back here and save those changes. So I've saved those changes and it recalculates. And you kind of see where it went and it put the lower limit at 0 and it's got the standard deviations on there. So I've got a little bit more information as far as what's going on the chart. So it looks like it didn't save the edits to the chart value. I'm not sure exactly why it did that. But this gives you an idea of what you could do. So if I was doing my mini project and I had collected all the data on the cycle time, or I had somebody provide me with the data on cycle time for the blood tests, I would throw it into engine room like this, do this little tool. I did it because I wanted to find out whether the process was under control. That's the why I use this chart. And then my interpretation would be is that the individual moving range or the X portion looks under control and the range does not. It looks like it's out of control, and that would be my interpretation. Another thing we can do, just to share this with you, since we're doing this on a more exploratory basis, I'm going to go into settings. I'm going to look at the X chart settings. And what it's doing right now, it's doing test number 1 is any point outside the control limits is on. So that's what it's flagging. What I'm going to say is I'm interested in any kind of weird behavior or systematic behavior in this control chart. So we know that in a control chart, if the process is under control, the data is behaving randomly or in a normal fashion between that upper and lower control limit. but there are also other things that are pretty unusual from any kind of process that I might want to flag that happen with about the same frequency as being 3 standard deviations away from the mean or the center line. So some of those things are 9 points in a row on the same side of the center line. That's pretty unusual. 6 points in a row increasing or decreasing. 14 points in a row alternating up and down. 2 of 3 points beyond plus or minus 2 standard deviations. 4 of 5 points above, etc. So I'm going to go ahead and just sort of light all these up. I'm going to turn all these on so that this is automatically going to look for all those sort of unusual situations. And I'm going to go ahead and save changes again. And I see when I did that on the X chart, I actually did get one failure. So it failed test 3 right here. And let's go see what test 3 is. So test 3 was 6 points in a row, increasing or decreasing. So let's see. So I've got 1, 2, 3, 4, 5, 6 points in a row increasing. So that's why it failed on test 6. Now, maybe that's significant, something I should investigate. Maybe I can find out what was happening during that period of time in the day when those data points were taken, and those observations. Maybe not, but it's something that was flagged on the control chart and something I might want to look at. Okay. I guess the other thing that I want to sort of point out, let me go ahead and, you can do a snapshot of this. You can annotate and put a note anywhere on here. So if I put a note, let's go ahead and say failed test 3, right? And I might put that note, closer to where one of the thing that actually failed was. All right. So I can do that. I could also go back, save changes. I can also take a snapshot of this, and I'm going to right click on here, copy image, and I can open up a Word document, and I can go ahead and paste this whole chart into a Word document if I want. And that's what you would do as part of your mini project. All right, so that was a lot of talking on my part, but I wanted to walk you through that, show you how quickly and how fast you can potentially do some of these tools, especially if you're using a statistical tool with Engine Room. Any questions on that at this point? So I get a hand raise if there's any questions. And it looks like there are none. Feel free to go ahead and look at this again. And hopefully that'll help you in your mini project, and also doing a control chart potentially for your project, either in the measure phase, analyze phase, or potentially in a control phase. All right. Go ahead and stop share, come back. I'm going to go back to screen share, go back to my PowerPoint, which is right over here. Screen share. Let's go with that. All right. So just so you see where we're coming from. So that was St. Sigma. Just a little sort of FYI, you might sort of wonder what we can see or what I can see from your performance on different questions. So we were just doing session, we're just doing session 7. So these are the number correct and the percent correct for people that did those tests. This actually wasn't your class, but it was a previous class. You can kind of see that the questions are color-coded. So if they're between 70 and 79% of percent correct, it flags that question so we can go ahead and talk about questions in a little bit more depth. So I just want to let you know a little bit about some of the capability that I have, some of the things that you can't see, but I can see for the whole class. All right. And finally, for hidden gems, one thing I like to say is for control charts, it's expressing the voice of the process. We've talked about in the define phase, talking about the voice of the customer. Control charts can be thought of as the voice of the process. You can look at the control charts and try to discern what the process is trying to tell you, at least from a median value or a mean value and a range or a variance standpoint. Now, one of the things is when we're looking at control charts, those are, extra work. Chester talked a little bit about, how do you make things maybe a little bit more friendly for people? It tends to be implemented and sustained more effectively. So we're not about just, say, record data for the sake of recording data. And ultimately, the focus of Lean Six Sigma is to prevent defects. And we should not use elaborate methods, but we should measure and push things upstream. So go back to where things are happening and try to eliminate those problems, those defects from occurring in the first place. So this is our second phase of the DMAIC process. Measure, the second phase, which is measure. I want to just give you a reminder, make sure you review the toll gate questions. So those toll gate questions are down here at the bottom. So they occur at the end of each one of these sessions. These are the questions that you would be asking during that phase. And then also want to make sure that you remember to watch those videos. I especially like the video by Scott Sink on process characterization. So those are the hidden gems for tonight, and that concludes our session for this evening. Are there any questions anybody has? Project questions, questions on the MoreSteam material, engine room questions, we'll take them all. Okay, so with that, I'm happy to wrap it up tonight, and we will see you guys next week. Be sure to send me an email or give me a call if you have any questions or need to chat about anything you're doing. Okay, take care and good night. To stop recording.